Dave. I'm your friendly neighborhood membership director. Many of you have either met me in person or received an email from me. If you haven't met me, I want to meet you. I try to meet everybody in the club. I want to make sure everyone gets to know who I am. But one of the cool things about being a membership director is I've gotten to welcome a lot of new people, not just to the club, but to the hobby. And so I thought it would be a cool idea to start doing a series of presentations aimed at people who are brand new to astronomy, who have just gotten started. And so tonight's presentation is going to be on proper deep sky observing technique, getting the most out of your observations. So, what is deep sky? With my obligatory image of the Orion Nebula. So, this is a deep sky technique presentation. And like Jennifer's beloved Matryoshka dolls, I've always said that astronomy is a hobby that contains many hobbies within it. There's a lot of different ways to engage with this hobby. For example, there's planetary and solar observing. This includes the moon, the planets, the sun, things within the solar system. Technically, it should include comets, but I consider them something else because comets are weird. There we go. There's solar observing, another hobby. By the way, this is the only dangerous form of astronomy. So if you are interested in solar observing, get a proper filter. And deep sky. So this is the practice of using your telescope to observe objects beyond the bounds of our solar system. It includes galaxies, nebulae, star clusters, and I include comets in this category even though they're part of the solar system because comets are weird. See, comets require the same basic techniques that the other deep sky objects do. So I consider them honorary deep sky objects. All right. The thing they all have, except for comets, in common is the fact that they're very, very far away, and therefore they're very faint. So if you're new to the hobby, you might think, okay, I line this thing up, I look at the eyepiece, and I see it. But actually, we can learn some techniques to get the most out of our observations. So this leads us to the central challenge of deep sky observing, what all of my techniques tonight are going to boil down to. Your job as a deep sky astronomer is to squeeze every last ounce of light out of what you're observing. Let's talk about how we do that. First of all, I hate these. These are spotlights. Artificial light is going to bounce off the atmosphere. It's going to make the sky behind the object you're trying to view brighter. It's going to cut down contrast. You won't see the object. So my first tip, get somewhere dark. A second tip is aperture is king. So when we are observing deep sky objects, and we are trying to get the absolute most out of the smallest amount of light trickling down from the heavens, the more aperture you have, the more of that light you can gather. So the bigger the opening of your telescope, the bigger your bucket for gathering light from distant stars. I say aperture is king, portability is queen. Right? Because your telescope should gather light, not dust. You want to make sure you're buying something that you're actually going to use. All right, so let's talk about the Mark I standard issue human eyeball. Typical factory specs, pupil, lens, retina. This is actually the most important piece of equipment when you're doing astronomy. And most of what I'm going to teach you tonight is how to get the most use out of your eye by understanding how the human eye works. So, first of all, we know about proper dark adaptation. When you get out somewhere dark, your pupil expands. So it's not enough to just get somewhere dark. You want to make sure that you are not losing your dark adaptation because the bigger your pupil, the more of the light you've bought that huge telescope to gather, you can actually get into your eyeball so that you can use it. And yeah, so we know that two main things happen when you get dark adapted. The first is obvious, your pupil gets huge, right? That's just like your telescope, aperture is king. You want a nice big pupil. The second thing that happens is that we switch from using the cones of our eye to using the rods. So you have two kinds of cells on your retina, cone cells and rod cells. Each cone cell is attuned to one of three colors, red, green, or blue. And then your rods don't discern color, but they do discern differences in brightness. and your rods are capable of seeing dimmer light than your cones are capable of seeing. So dark adaptation, pupil gets bigger, we switch to using the rods. That is why, when you look through the eyepiece, you almost never see color, right? Most of your objects are going to be gray like this. That, by the way, is one of my sketches that I got an award for. Woo! All right, so we're going to talk about the first human eye exploit. There is a flaw in the design of our eyes, which is that our rods are not very sensitive to red light. And this allows us to cheat, and we can use red, dim light to read our star charts and find our way without ruining our dark adaptation. So, Dennis was talking about our dark sky sight earlier tonight. If you do decide to come out and join us, we observe what's called light discipline, and so we only use dull red light. Just like this soldier is doing, trying not to ruin his night vision by using dull red light. If we can keep our eyes dark adapted, that saves us time, because it takes about 30 to 45 minutes to regain your adaptation if you lose it. So it's better to adapt at the beginning of your observing session and just maintain adaptation the whole time. Okay, so the other thing we can do is we can exploit the layout of the retina. So this is what the human retina looks like. We've got our optic nerve that connects in the back. There's a blind spot here. And then we have this region called the fovea, which is densely packed and highly sensitive. When you look at things, you're actually pointing your fovea at it so that you get a better view. When you read, your fovea moves across the page to read. So, the problem is the fovea isn't good for deep sky observing because it's actually all cones. So what we do, if you look, the fovea is densely packed with cones, and then the region just around the fovea is densely packed with rods. This is why we practice something called averted vision, right? If you look directly at your deep sky object, the light's going to hit the cones and you won't see much. What we actually want to do is look next to the object. So here's an example using Messier 33. This is the Whirlpool Galaxy. This is another one of my sketches. This is about where I would look when I'm trying to observe this object. So I don't observe it directly, but I put my fovea right here, and then the rods of my eyes around it are able to see more of this faint object because they're more sensitive. And one thing I'll usually do is I'll roll my eye around the edge, and I'll let this image hit every other part of the retina to build up the image. So that's a practice called averted vision. You're basically going to want to catch it out of the side of your eye. Choosing the right magnification. So when we're observing deep sky objects, we want to make sure we're observing at the right magnification. Generally, we want to start on low power and work our way up. This is because there's a trade-off when we go up in magnification. Every time you increase magnification, the object does get bigger, but you lose clarity, it gets a little blurrier, and you lose some brightness. It's going to get a little dimmer. That being said, yeah, here you go. Take note, as magnification increases, brightness decreases. And our goal is to get as much light as possible. But a little bit of magnification can actually help a little bit. Because as you cut down the brightness, with a little bit of magnification, you can actually cut down the background glow. And you may find that your contrast increases a little bit. So it's good to experiment and find the sweet spot. Personally, I like about 90 times for a lot of work. All right. Your eye is not a camera. It is a multi-purpose sensor. Mainly, your eye is a contrast detector. So, again, if you think you're just going to look at the object and just see it, really what you're looking for is to increase the contrast, get the most amount of difference between the object and the background. This could be done by finding the right magnification. It can also be done with filters, which I'll talk about in a little bit. Another important point, just like a Tyrannosaurus Rex, our vision is based on motion. So we are actually really good motion detectors. Even if you don't see the object itself, if it moves, it can sometimes stand out to you. So sometimes when you're looking for something particularly difficult to find, it can help to sweep a little bit, or even to tap on your tube so that everything jiggles a little bit and you might find it pops out at you. I do that sometimes at our outreach. If I'm showing something a little tougher, I'll tap the telescope while people look through it. They go, oh, now I see it. Okay, relax. Relax. If you sit comfortably, breathe in and out. Don't forget to breathe. Honestly, the first, I don't know how long I was observing, I didn't realize that every time I went to the eyepiece, I held my breath. Don't do that. Breathe. Your brain needs oxygen. All right, so here are some of my tips for specific classes of objects. Star clusters are kind of deep sky easy mode, right? They're just stars, not that difficult usually. So they're a good way to start off. But a couple tips. For one, and especially if the star field is rich, and there's a lot of stars, introducing motion can help, right? So again, sweeping, tapping, this kind of thing, and you'll sometimes see like a knot in the background of stars, and that will give away the position of the star cluster if it's hard to differentiate. Globular clusters like this are sometimes fuzzy, and these can be a lot of fun because you get to play around with them a little bit and experiment with different magnifications. These respond very well to magnification for deep sky objects, and sometimes you might find they just remain fuzzy. Sometimes you can resolve and get little pinpoint stars out of them, so that's a little thing to go for if you're going for a globular. See if you can resolve it. Try maybe magnifying it a little bit. Here's tips for galaxies. I think these are probably the most difficult because they're the furthest away, right? All the other DSOs, deep skies objects, they're in our own galaxy. These are other galaxies. Some tips here, a little bit of magnification maybe to help increase contrast, tapping the telescope, introducing motion, look with averted vision, and one thing to look for when you're using your averted vision is see if you get any hard edges that indicate a dust lane maybe in the galaxy. Let's see here. Nebulae, tips for nebulae. These are very diffuse and blurry. Actually, these are probably the hardest objects. Probably harder than galaxies, because sometimes they don't have a hard edge, they just sort of fade into the background. So, if you can increase contrast with these, that could be very helpful. And one thing I like to use is, where is it? O3 filter, right? A lot of nebulae glow in that part of the spectrum, so if you use an O3 filter, it'll cut out everything else and help bring out the nebula.
Hey Dave?
Yes?
What is a nebula?
A nebula is a big cloud of gas in space. And nebula is Latin for cloud. And they're glowing because of starlight heating up the gas and making them glow. There are these things called planetary nebulae. They are not planets. It's the worst name ever. But they do respond very well to O3 filters. Now, planetary nebula can be a bit of a challenge. This is my sketch of one, and the size of the dots actually represents the brightness of the star. So it's not entirely realistic. A lot of times, these will just look like a star. So if you're hunting one of these smaller planetary nebulae, an O3 filter can dye it blue and make it stand out in the background.
Dave, is that the blue snowball?
That is actually the blue snowball. Good catch.
Dave?
Yeah.
Because some of them appear like stars, sometimes this is a case for using magnification.
Yes, that's the other thing. You can really crank on some of these planetary nebulae without worry, because they're not dim, they're just small. All right, comets. Here's some tips for comets. These are my honorary deep sky members. These will often really test your skills, because some of these comets are particularly bright, easy to see. Some of them are very, very faint. My notes on this comet, I actually wrote that I felt it more than saw it. Right? It was so hard to pick that one out of the background. You kind of want to use all of your techniques, your averted vision, play around with contrast, be patient with it. One thing that's very important to do when you're observing the comet is to make a note of where it is related to the background stars, because comets do something that none of the other deep sky objects I've talked about do, and that is that they move. They will actually move over time, and that's the giveaway that it's a comet. And the reason why the comets are different from all the other deep sky objects is because comets are weird. All right, thank you very much. That's my presentation. Yes.
You know why comets are like cats?
Because you never know what they're going to do.
Well, they both have tails and they do precisely what they want to do.
That's right. Comets and cats have tails and they do whatever they want to do. Before I wrap it up, did anybody have any questions? Yes, Susie.
What is an O3 filter?
Oh, yes, an O3 filter. So O3 is not ozone, well, we might think of O3 from chemistry. What it is O1 is neutral oxygen. O2 is oxygen that has been ionized. O3 is doubly ionized oxygen. And a lot of nebulae contain this ionized oxygen. It glows at a particular wavelength of light. And so an O3 filter blocks light of all the wavelengths other than the one associated with doubly ionized oxygen. So it can help to greatly increase the contrast in many what we call emission nebulae. These are nebulae that have heated up and are glowing with their own light.
I have a question.
Yes.
When you were talking about dark adaptation
Yes.
and using red lights, what do you do about using a laptop computer?
So that's a great question. Personally, I only use like paper charts and that kind of thing, mainly for that reason. But there are star chart programs for things like your laptop that actually have a night mode. Stellarium is free, and it has a night mode. And it'll turn so that it's all red and black on your display. And I would recommend just going into your settings before you go out to observe and set your computer not to turn the screen off if there's no activity. That way when you go to wake it up, you don't get blinded by it.
And
A lot of our astrophotographers use their laptops because they're using computerized things, and they have a little dome as well that they put over it to help cut it out for the rest of us that are doing visual observing.
And you can order overlays that will lay over the
Right.
screen and do a much better job.
Oh yeah, that
than
too. You
depending
can put
on
a red
the
overlay over it as well.
I'll add that if you're an iPhone user, there's a way to make your phones go red
Yeah.
too, so if you don't know that,
But-
there's a way to make it.
But a lot of these devices leak,
Yes, yeah.
and they really don't cut out all the wavelengths that you want to cut out. So it's a good solution, but it's not a great solution.
Right.
The overlay is the best.
And if you're gonna go to the swamp and you don't have a red flashlight and don't feel like cranking out $5 for one, we've got rolls and rolls and rolls, probably 200 rolls of red cellophane tape that can go over your white light flashlight and works perfectly.
And if you want to get some tape, it's called tail light tape, and you can buy it at Walmart in the auto parts section.
I've got 100 rolls of it, just tell me and I'll get you one.
Excellent. Yes.
What other filtration can you use on the scope itself other than the O3?
So there are other filters. For deep sky, I feel like O3 is the workhorse. I get a lot of work out of my O3 filter. There is also hydrogen beta. It's a different wavelength associated with ionized hydrogen. And some nebulae respond to it rather than O3. The Horsehead's a good example. They also sell color filters, which just simply filter for different colors, red, green, blue, that kind of thing, which are useful for observing the planets because, say you put a green filter on Jupiter, the red spot turns black and it becomes visible to you. So there are color filters as well, and polarized filters to cut down the glare from the moon.
UHC.
And the UHC, ultra high contrast, I've almost forgotten. So there's a kind of filter called a UHC filter that is a little bit more forgiving than an O3. It lets a little bit wider range of light through, but it's mostly cutting out what's associated with light pollution. So it kind of helps to mitigate the light pollution a little bit. John,
A
you
lot of
have
the UHC filters will have 3 bands. And one
Right.
of them will be oxygen 3.
That's right. So most ultra high contrast or UHC filters like the Orion Ultra Block or the Lumicon UHC, they'll allow the O3 part to come through. I forget what the other one is.
Hydrogen beta is the other one.
Hydrogen beta, and then some of them allow a little bit more as well.
Yeah.
Yeah.
But
Yeah,
and what's
there's a
really
swan
critical with those
filter, too.
filters is to get the narrowest bands you can get. Don't get the wide band ones.
What was that, Roger?
They're useless.
The swan filter for comets.
If the comet's the right type.
Yeah,
That is something new I learned. I didn't know what the swan filter is.
yeah. They're also just for information like the UHC filter. If you're using a 8-inch scope, it's going to turn the scope into about a 4-inch scope because it's going to block out that much light.
Right. So every filter, there is no filter that gives you light, right? A filter always works by cutting out some of the light. So even with my beloved O3 filter, I'm accepting a small amount of light loss to cut the background way down. But I feel the increase in contrast makes it worth it.
If you come out to the swamp where we're doing more serious deep sky stuff, most of the people that go out to the swamp have these filters and they can show you what they do and what the difference is.
Absolutely.
When we're doing public outreach at Hanna Park, when we're looking at the moon and the Orion Nebula and Saturn, it's not really anything that will showcase these filters to you. So that's another reason to go to the swamp, is you get to look through more interesting and more powerful stuff.
Yeah, definitely.
And also talk about that green thing you point at the sky with.
Oh,
as far as light
yeah.
adaptation.
Yeah, my green laser.
Yes.
Yeah, I use a green laser when we do our outreach events to give tours of the sky. I wasn't at Hannah Park this last time because I was at the Mosh giving my sky tours. So I think the whole city of Jacksonville saw this green lightsaber shoot up every so often. But obviously when we're doing our dark sky stuff, I'll use it a little bit, but mostly we don't do that. And they're forbidden at the Winter Star Party because they ruin astrophotos. Yes?
Another question. Can you talk a little more about eyepieces? I've seen that for a given size eyepiece, you can spend $25 or $1,000.
Yeah.
At some point, obviously, more money is, I guess, better.
Not
But
necessarily.
at some point, there's probably diminishing returns on, like a TeleView. Is that a?
The TeleView eyepieces are very nice.
And very expensive.
Used.
Yeah. Yeah, getting them used is good if you can.
One
They
of the
are very
things-
expensive. My understanding is they're worth the cost. I actually don't know that much about eyepiece and buying eyepieces. I've been educating myself because I've been thinking about expanding my eyepiece collection a little bit. I've thought about learning a bit more about it. Maybe my next presentation might be on eyepieces because I want to learn more about it as well. One thing you want to do if you're thinking about buying eyepieces from scratch and you don't have any for your scope and you want to buy a set, getting a set together is often a good deal that you can buy a set of eyepieces. You can find the calculations online to look up what your minimum and maximum magnification should be for your telescope because I talked about the human pupil earlier. There's this thing called exit pupil. It's how big is the beam of light that's going to come out of your eyepiece. And so there's an ideal minimum amount of magnification that if you go any lower, your power is so low that it spills light across your iris. You actually don't get the benefit of that low magnification. So for a 10-inch aperture, that's usually around about 25, 30 times magnification. Depending, your iris doesn't actually open as much as you get older as it does when you're younger. And then there's an effective maximum, where if you go too high in magnification, it hits such a small part of the retina that you again have a hard time actually gaining the benefit of your eyepiece. And then in the middle, you want an eyepiece that gives you a 2 millimeter exit pupil, because that's kind of a sweet spot for getting really good magnification. So with my telescope, that's where I mentioned earlier, this is sort of sweet spot when you're playing around with magnification. My telescope 90 times is about there. And I tend to get the best views by taking my 25 millimeter and throwing it in a Barlow so that I get 90 times magnification. But that's a whole subject about eyepieces. A lot of these guys know a lot more about it than me, though, if you want to hang out afterwards.
Simple thing
And
to
I'm
do
definitely
is
thinking
come
about
up
making
and
that
hand
another
it.
presentation, maybe coming up here this year. Excellent question.
You get out to the swamp with us. We are very sharing people. We love to share our eyepieces.
Absolutely.
You can come out and either look through our scope or your scope using our eyepieces, and then you find out what's comfortable for you. Because some of the most expensive eyepieces I can't use. Other ones, you might have a $30 eyepiece that's wonderful for you. It all depends on your eyes and what you're looking for also in your scope.
Yeah, Dennis knows I have a gap in my eyepiece collection because I'm constantly borrowing his aid.
David,
Yes.
you might want to mention that that most people do not need eyeglasses when they're looking through a telescope.
Oh yeah, since we're on the subject of eyepieces, if you do wear eyeglasses, long eye relief is a thing to look for when you're shopping for eyepieces. That means that your eye can be further from the eyepiece and you get the functionality. But if you are near or farsighted, one of those two, then that means that you need glasses for an issue to do with focus. And you can actually take your glasses off and just change the focus on your telescope. And your telescope is now your glasses.
As long as you don't have astigmatism.
Astigmatism is different. Your telescope can't correct for that.
Yes, it
But they
can.
do
There are
The
correctors
eyepieces can.
for it.
Oh, there are, okay.
Again, you get into a function of money.
Yes.
I mean, I'm perfectly happy looking through my 70-year-old design Urfel. It cost me $15 versus looking through an $800 TeleView, which I can't afford and never will be able to afford. So
We call those house payments.
Yeah, you go to the swamp, or when you're out observing with somebody who's got eyepieces, ask. There's nothing more I like to do than show off my stuff. And I would love for you to look through mine. I'd love for you to look through Dennis's and borrow Dennis's. Borrow mine.
Especially that
In case you haven't noticed, I'm rather large and you'll give it back too.
There's two different sizes. You got the 1 1/4 and
Me
the 2
and other
inch.
people.
Right.
So how
Like I said,
long
we
does
could,
it
we
take
could
to
definitely
get
go
to
and
the
go and go
swamp?
about eyepieces. Did anybody else
From
have any
where?
questions about observing technique?
From here.
Probably
How long
take
does
it 45
take?
minutes
Yeah,
from
say
there.
40 minutes, yeah.
I've been an hour.
Except at rush hour.
And one of the benefits of the club is last year, through donations and funded things that the club paid for, we gave away about what, $2,500 to $3,000 worth of eyepieces, Dennis?
Yeah, to the
Oh,
club
yeah.
members.
To the club members.
Including
As
some of
door
those nice
prizes.
expensive televiews.
Yeah, we gave away one eyepiece that's worth $800. Wins everything.
Question about the swamp light. Eric said that he spotted logging trucks going out there, and I was wondering if there's any follow-up on that. Have they worked the dip pond area
Anybody
or
been out
not?
there since you?
Now, they're doing a little bit on the other side of the main road. They've got trees marked on our side, but it's not far enough back to really get to us yet.
Okay.
There's a lot of pine bark beetles in there. So it's starting to make the field a little bit bigger.
Hey, Dave,
Yes.
I'm new, nice presentation.
Oh, thank you.
Would you be willing to share it through email?
Yeah, I can email you if you wanted just the slides. You want me to email that to you?
Be great.
Yeah, absolutely. I got you on the list, so I'll send you an email.
All right.
Nice.